So I'm driving with my son, and I'm staring out the window, and he's talking, and I'm thinking about stuff. And he says, "So, Dad, did Steve Jobs invent the computer?" And that just pulled me out of whatever I was thinking of. What? And Steve Jobs, the specious individual who co-founded Apple, is not the inventor of the computer. And so this launched a lengthy lecture on the history of computing that he eventually threw me out. And it led to this presentation. So, who invented the computer? No individual invented the computer. The computer and computing is a product of mankind. And I did some reading on it. It was kind of interesting. It can take us all the way back to numbers. So just about every known language to man has at least words for the numbers 1 and 2. And developers, we always like to talk about layers of abstraction. It never occurred to me about numbers are a layer of abstraction, kind of the first layer of abstraction. And you could say that this was the beginning. Now, once we have numbers, then we have a numbering system. And as I said, some of these languages didn't have full-on numbering systems. We do have base 10 systems, ones place, 10 place, and so forth. So this led to, principles of math, square roots, blah, 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 homework, all the things we have today, right? This is another stepping stone. Now, mankind, we like to develop tools to help us, right? And so we always talk about automation. This is automated, this is manual. So obviously the early tools that we had were a manual process. One of the first was the Mesopotamian abacus, which was developed around 2700 BC. Now, I can't possibly cover all of the interesting machines that have been developed over the years. Okay, so I grabbed a handful that I thought were worth mentioning, were kind of unique. This is a Chinese self-pointing device. And based on documents and so forth and legend, they believe that this box has a bunch of gears in it, and it has a differential, which was one of if this is true, it's the earliest man-made tool or tool period that has a differential gear in it. And the idea is you take this little guy and you set it down and you point it south, and then as you're running around with your armies and your horses, the gears, no matter which way you turn this thing, keeps the little guy pointing south. It's used as a compass. And there's legends about how this thing played a key role in defeating this army and that army, and it's kind of an interesting tool. One of the things that the paper I read about this talked about was how these gears and this differential was used in some of the early analog computers. Now, how many people here knew that there was such thing as analog computers? Okay, I've heard that term before. I always thought it was a joke, like this is my pencil, this is my analog computer. This is an example of an analog computer created in 1959. Now, there are many analog computers. This is one. It's made up of gears and transistors, and it solved differential equations. And it still functions today. It's in a museum in Poland, and it's one example of an early analog computer. This is regarded as the earliest known analog computer. It's I try to pronounce this, the Amphicatheria, and it was discovered in 1900 in a shipwreck off the coast of Greece. And it has very complex gears, and they estimate that it was built around 87 BC, and it was used to navigate, to calculate, astrological positioning. But one of the interesting things that I remember going to school was talking about Morse code. So computers, right? We always talk about binary, 2 states, zeros and ones, on and off, right? And that's what Morse code is. There's 2 states here, dashes and dots. But there's actually 3 states. There's a third one. It's silence, right? So when somebody hears this, they hear the dot dash, and then they hear the silence, and that's the indicator that I'm about to go on to another character. But when it came to machines, that silence was often part of the dot or the dash. So some very creative people said, well, you know what? Let's have these be fixed length. So in Morse code, you see the A is only 2 bits long, whereas the B is 4 bits long. Well, in early computing, they said, well, let's just make every character 8 bits, and we'll call it a byte. Right? So everybody's with me on that? So that's kind of the history of that I thought was kind of interesting. Morse code came around in 1836, and you're all familiar with the Morse code systems. And I'm sure you've all in your career have heard about the ENIAC computer. Right? This computer was developed in 1946, and it was funded by the military to calculate artillery things. And this computer had over 17,000 vacuum tubes. And I've read that people would wear roller skates and roller skate up and down these aisles on multiple floors just to plug in new vacuum tubes that would burn out. And they had one huge building, like bigger than any Walmart you've been to, with the computer, and they had another one just as big for the air conditioning to cool that second building. It's amazing that this would be built. I mean, would any private enterprise take on such a task? Probably not. So, after I'm doing this research, I started thinking about computer languages, because a lot of us here are computer programmers. So, I did a search on the history of computer languages, and I was thinking of C. I knew of maybe 6. There are so many more than this. And they go all the way back to 1943, right? Put that in that. Now, they had conceptual, analytical. This was more of a conceptual design. That early one in 1837. But then, you get down here in the early 50s, is when you start seeing Fortran, some of those Fortran, Comtran, some of the things that many of us took in college. And then, 1960s, you get your COBOL. I actually thought I was going to be a COBOL programmer when I came out of school. The whole Y2K thing was going crazy. Well, that was 1960. So this spans quite a ways back. Now, let's talk about where we're going. Now, everybody loves to try to predict where we're going, but there's this thing called the singularity. How many people have heard of the singularity? Okay, it's worth going on. If you go to Time Magazine and Google Time Singularity, you'll read this article. And Moore's law talks about how computer processing is going to double every
2 years,
18 months. So 18 months, 2 years, which has been very, very accurate. Well, they're saying that around 2045, computers are going to start. They're not going to need us to double this power anymore. And once that happens, Moore's law is out the window. We're talking fractions of a second. And they're saying, think Star Trek, right? Cyborg, the Borg kind of nonsense. But it makes for a very, very interesting article. So my call to action: check this out. The singularity. It's worth